Good morning, gentlemen, and welcome to Form 5 AP 2021. I know it's not the beginning that we all hope for, but I'm sure it will improve, and soon myself and Mrs. McDonald will see you in our classrooms, and we will be able to explain all the details to you. Despite the funny start, I hope that you will conquer this year. You will get amazing results in maths and you will once again beat the best private schools in the country in the AP program. Well, to get there, unfortunately, we have to start with a little bit of a basic revision because we need to move into a very special exponential and logarithmic function in the AP maths, and that's the natural logarithmic function, or what we call the ln. And for that, we need to revise a normal exponents. Starting with basic exponential equations, and we're starting with a type 1 of exponential equations, and that is when I have only one term on one side with the unknown in the exponent and the number on the other side. I hope that you remember that in order to solve such equation, you must isolate your exponential term, get the same base, and then solve by comparing the powers, which means that in example 1.2, I would first divide both sides by 2 to get 25 to the power of x squared minus 1, which is then equal to 1 over 625, or 625 to the power of minus 1. As you know, you're bringing the positive value up, and now we need to get to the same base. Obviously, between 25 and 625, the common base is 5, so we've got 5 to the power of 2. X squared minus 1 is equal to 5 to the 4 times minus 1. I'm just going to do it only once, hoping that from 2 exponents you have in your little finger. Therefore, we have 5 to the power of 2x squared minus 2, we multiply it in, equals to 5, we multiply the powers to the power of minus 4. So what we can see is that we get that 2x squared minus 2 must be equal to minus 4. As you remember, you need to compare the base. As we have the same base, we have to compare the powers. Now, please, in ADMATS, well, math in general, please do not refer to let's drop the base, or what's worse, divide the base. We compare the powers as base is the same on both sides. And we get that 2x squared is equal to negative 2. Okay, which means that x squared will be equal to minus 1, and then we're sitting with a problem. Luckily in ADMATS, it's not a problem. In a normal maths, you will say, therefore, there will be no real solution, and that's very important. We were always saying that we cannot make a statement no solution. We can say, or we must say, no real solution for x. There will be a solution in a non-real system of numbers, which we'll be talking about it a bit later in a year. In ADMAT, you will see this often. The answers that we get are not necessarily all pretty numbers, your half or minus 7 over 12. We get all sorts of numbers, and you have to get used to that. Right, so that was example 1.2, not too complex. We need to isolate the exponent and then solve. Similarly, with example 1.3, I need to get 25 to the power 25 to the power of x plus 2 on its own. Divide both sides by 5. You can always work with your calculator. You must check it. You must see if I'm getting the right answers. I get 625 in this case. Therefore, once again, we get 5 square, so 2x multiplied through plus 4, and then our 625 as 5 to the power of 4. Okay, comparing, we've got the same power, therefore we have 2x plus 4 is equal to 4, and I get that 2x is 0, which will give me x equal to 0. Okay, so that's a nice solution, nice in terms of it's a solution that we like. So these ones are the two very basic ones. Isolate exponential term, make it on its own, solve by getting the same base, and compare the powers. I hope it's as easy as a Form 3 work, so we can look at the second type of equations, and that is when we have a common term. If you look at these two examples, example 1.5 is slightly different. We're going to look at this just now. I said that we're going to look now at the examples where we've got a common term. And in example 1.6, the common term is 2 to the power of x. However, you must be very careful with isolating this term. So the best for us is to rewrite all the powers as a single powers. So I will have 2 to the x minus 5 times 2 to the x times 2 to the 1, okay, equals to minus 144. So 2 to the x now I can see clearly as my common factor. Removing the common factor leaves me with 2 to the x times 1 minus 10, which is equal to minus 144. Right, so it's minus 9 times 2 to the x is minus 144. Therefore, we're back to our type 1 of the equation, which we just did on the previous slide. We need to have 2 to the x on its own on one side of the equation, and if we divide both sides by minus 9, we get 2x is equal to 16. Okay, and it takes us, like I said, back to a very basic example. 2 to the x is 2 to the 4. Therefore, in the first example, we get x equals to 4. Okay, so we went step up with sort of a level of difficulty with the equation, exponential equation. And we said that we don't have only one term, we have more than one term. In this example, we have 3, but we had an exponential term, 2 to the x, as a common factor. Now, what's with this question 1.5? 1.5, I will need to approach in exactly the same way as 1.2 and 1.3, because I've got only one term with the exponent, and I will have to isolate this. So if I only have 3 to the x times 4, then I want to have 3 to the x times 4 on one side. Therefore, everything goes to the other side, and it gives me a 20. Okay, in a similar way as with the previous example, we got to this point where I've got an exponent multiplied by a number and the number on the other side of the equation, which means that I need to divide both sides by 4. Okay, and now I stopped, because it would be lovely if by dividing by the number in front of the exponential form, I got to something that I can create as a common base. There is no ways that we can find a common base between 3 and 5. So what now? Okay, I hope that you quite easily see that there is no problem, because we actually can log both sides. Okay, so you must boys remember that if you have a one term on a one side of your equation and a one term on the other, and you cannot make the same base, we will need to log both sides. So if I log both sides, and I will choose the most common log, and that is the log with a base 10, Remember, here is the base 10. We just don't write that base, mathematical notation. And using the exponential law, we know that if I have a log of a to the power of b, the first law says that it can be written as b log of a. Okay, so that x comes to the front. I have x log 3 is equal to log 5, which means that x will be log 5 over log 3. Correct? Now you can take out your calculators. If there are no restrictions to leave your answer without the use of calculator, then on your calculator, you do your button log 5 over log 3 and you get your answer. Okay, so please pause, take out your calculators and make sure that you get the same answer as I did. And this is 1.46, correct to 2 decimal places. In a previous slide, we just did an example where we had 3 terms, but in that example, we had a common factor of 2 to the x. The question 1.9 is also 3 terms, but my question to you is, as you look at the 1.9, is 2 to the x a common factor? It appears in a second term here, but as a first term is 2 to the 2x. So I hope that you remember it from the Form 4. This is one of the more complex equations with exponents. It's in fact a trinomial. And if you don't see it, if you see the combination of 2 to the x with 2 to the 2x, a combination of 3 to the x and let's say 3 to the minus x, because that's the same as 1 over 3 to the x. If you don't see this as a trinomials, then please try to use k substitution. So what I would do, I will say let 2 to the x be k. Then how my equation looks? Well, I have now 2 to the 2x as a term 1, so that will be k squared minus 7k equals to 8, but I can see that I'm getting a trinomial. I get a quadratic equation, and if I want a trinomial, then it must be represented in a standard form. I can factorize. I get, in this example, k minus 8, k plus 1 equal to 0, and then k is 8, or k is minus 1, but k was 2 to the x, so I can go back and say 2 to the x is equal to 8, or 2 to the x is equal to minus 1. Now what happens with positive base to any power, or positive base to any power will always be positive, therefore there will be no real solution for x for this equation. You can choose any x. You can choose a x minus a million. Now 2 to the power of minus a million is just 1 over 2 to the power of positive a million. So it will be a tiny fraction, but never negative. We can solve on this side quite easily. Once again, even the most complex equations with exponents, our trinomial equations with exponents, will lead to a basic exponential equation where we've got a one exponential term on one side and the number on the other side. All of those examples ended up like this. Therefore, my only answer is x equal to 3. Okay, so those ones were the 3 types of equations with exponents, the basic equations with exponents. If you look at the worksheet once again, it is set for you to recognize the types of the equations in a very simple way. So if you look at the first section, questions from 1.1 to 1.5, we have those examples where we have only one exponential term and the number on the other side. Okay, in this example, which I just highlighted, it's not necessarily a number, but you can bring it all together. 1 over 27 is the same as your 3 to the power of minus 3, and therefore you can combine this with 9 to the x using, remember, basic equation, a to the x times the same base to the different power. What do we do, boys, with powers? Well, we need to write down the base, add the powers. I truly hope that for the matric ADMATs I don't have to explain that. But your first group, a first type, is the most basic one. The second type is when we are looking at common factor. So 1.6, 1.7, 1.8, those ones are your common factors. They are known as a type 2. So by factorizing it and removing a common factor, type 2 will lead you back to a type 1 equation. And then we have the 3 examples of trinomial. 2 are very similar. Please just remember you need to put the trinomials type 3 into a standard form to solve it. If you need to watch it again, you're more than welcome to watch the clips again. What you have to do now, boys, is you have to do the questions from this page that I have not done, and you must mark them using the memo that is given. But please, don't just read the memo. Do the questions, check with a memo. And the questions that you are required to do, please, are the questions 1.1, the questions that I did not do. So question 1.1, question 1.4, question 1.7, 1.8, question 1.10, question 1.11, as well as question 2 and 3. Those questions will give you a total of 34. You have to mark yourself and you have to give me an indication of what your mark was. And it must be very close, boys, to 34 marks. Enjoy the first very basic exercise in an AP Maths class.